Welcome to Investigating the Universe, where we delve into the mysteries of the cosmos. Today we are going to unravel the enigma of impossible physics. Now you might be wondering, what exactly is impossible physics? It's a term coined to describe theories and concepts that seem impossible according to our current understanding of the universe. These are ideas that defy the laws of physics as we know them. Over time, however, some of these seemingly impossible theories have been proven otherwise. Remember, there was a time when the concept of quantum mechanics, with its particles being in two places at once, was considered impossible. But today, it's a fundamental theory in physics. So this journey we're embarking on, it's not about proving the impossible, but rather about expanding our understanding of what's possible. So buckle up as we dive into the fascinating world of impossible physics. Imagine if you could go back in time and meet your younger self or jump to the future to see what lies ahead. This captivating scenario is the very essence of time travel, a concept that has sparked the imagination of dreamers, scientists, and writers alike. Time travel is the idea of moving between different points in time, much like we move in space. It's a concept that has been popularized by science fiction, and it's one that has a basis in real scientific theory. Albert Einstein's theory of relativity, for instance, suggests that time is not a constant, but a variable that can be affected by speed and gravity. This has led some to suggest that with the right conditions, time travel might be theoretically possible. But there's a hitch. Time travel, while fascinating, is fraught with paradoxes that make it a conundrum in the realm of physics. Take the grandfather paradox, for example. This is the idea that if you went back in time and accidentally caused the death of your grandfather before your parent was born, you would not exist, and therefore could not have traveled back in time in the first place. It's a mind-boggling loop that seems to suggest that time travel to the past at least could create impossible situations. Then there's the future. If you could leap forward in time, you'd be entering a world that hasn't happened yet. This raises questions about determinism and free will. If the future is set and can be visited, do we really have any control over our actions? Or is everything predestined? These paradoxes and others make time travel a tricky concept to grapple with. It's a tantalizing idea, one that could unlock the secrets of the universe and our own existence. But it's also riddled with complexities and contradictions that make it a prime example of impossible physics. While time travel may seem like a fascinating concept, it remains a conundrum in the realm of impossible physics. Ever wish to teleport from your home to your office in a blink of an eye? Teleportation, as dreamy and convenient as it sounds, is a concept that's been part of our popular culture for quite some time. It's been widely represented in countless science fiction novels, films, and television series, from Star Trek's Transporter to Harry Potter's Flu Network. But what exactly is teleportation? Teleportation in essence is the theoretical transfer of matter or energy from one point to another without traversing the physical space between them. Imagine if you could disappear from your living room and reappear in your office within the blink of an eye. That's teleportation for you. Now let's delve into the science behind this fascinating concept. The idea of teleportation comes from the field of quantum mechanics, particularly a phenomenon known as quantum entanglement. This is where two particles become intertwined in such a way that the state of one can instantly affect the state of the other, no matter the distance between them. In theory, if we can entangle the atoms in our bodies with atoms at our desired location, we could theoretically teleport. However, the key word here is theoretically. In practice, there are several scientific challenges that stand in the way of making teleportation a reality. Firstly, we currently lack the technology to control quantum entanglement at a scale large enough to teleport a human being. Secondly, there's the issue of maintaining the exact arrangement of atoms that make up the human body. Any slight error could result in catastrophic consequences. Lastly, there's the philosophical question of whether the teleported person would indeed be the same person, or a mere copy. This is often referred to as the teletransportation paradox. So, while our desire to avoid traffic jams and long journeys may make the idea of teleportation highly appealing, the scientific reality is far more complex. Teleportation, while a favorite in science fiction, still stands as a challenge in the face of physics. Ever imagine traveling to a distant galaxy in no time? This is where the concept of wormholes comes into play, theorized as shortcuts through the fabric of space-time. The idea of wormholes originates from Einstein's theory of general relativity. To understand it, let's imagine space-time as a two-dimensional sheet. Now, If this sheet folds onto itself, it forms a tunnel-like structure, a wormhole. It's like folding a piece of paper in half and poking a hole through the two ends, creating a direct route bypassing the surface. This shortcut, if it exists, could theoretically allow us to travel faster than light, making interstellar voyages plausible. It's like being in New York one moment and the next, you're sipping a cup of tea on a planet orbiting Alpha Centauri. However, there are some significant scientific complexities associated with wormholes. For one, they are inherently unstable. According to theory, a wormhole would collapse upon itself almost instantly, trapping anything that tried to pass through. To keep a wormhole open, we would need a form of negative energy or exotic matter, substances that are not yet proven to exist. Another challenge is the size. Theoretically, most wormholes would be microscopic, not nearly large enough for a spaceship or even a human to pass through. Expanding a wormhole to a size suitable for interstellar travel is, at present, beyond our technological reach. Moreover, even if we could create and stabilize a wormhole, navigating through it would be another daunting task. The interior of a wormhole could be a high-energy environment, potentially deadly to any travelers. In conclusion, while wormholes present an exciting prospect for faster-than-light interstellar travel, the hurdles are monumental. They remain a fascinating concept in the realm of theoretical physics, offering a glimmer of hope to all those who dream of exploring the farthest corners of our universe. Wormholes, a fascinating concept, yet remain in the realm of the impossible, at least for now. Could humans ever become invisible? Now there's a question that has captured our collective imagination for centuries, from ancient mythologies to modern science fiction. The concept of invisibility, or the ability to be unseen, is indeed fascinating. The science behind invisibility is primarily about manipulating light. Light, as we know, is made up of particles called photons. When these photons hit an object, they bounce off, and our eyes detect these reflected photons, which allows us to see the object. Theoretically, if we could manipulate light in a way that it doesn't reflect off an object, that object would become invisible. This concept of invisibility is not entirely alien to nature. Some animals, like the cuttlefish, can manipulate the color and pattern of their skin to blend with their surroundings, effectively becoming invisible. But this is not true invisibility. Rather, it's a form of camouflage. Scientists today have been able to develop materials known as metamaterials that can bend light around an object, effectively making the object invisible. However, these materials work only for specific wavelengths of light, and not for the entire spectrum that our eyes can see. Moreover, even if we could create a perfectly invisible object, there's another challenge. If all light were bent around an object, none would reach the object itself. This means that, if a person were to become completely invisible, they would be blind as no light would reach their eyes. Invisibility, then, is a paradox. The more invisible you become, the less you can see. It's a fascinating conundrum, one that scientists and researchers continue to explore. So could humans ever become invisible? With current technology, complete invisibility remains a dream, but who knows what the future holds? We live in a universe full of mysteries, a universe where the impossible might just become possible. Invisibility, a concept that continues to captivate our imagination, yet remains a challenge in the world of physics. We've journeyed through the realm of impossible physics, exploring ideas that, while seemingly impossible now, could one day become reality. We've traveled through time, teleported across space, ventured through wormholes, and even explored the concept of invisibility. These ideas, once considered the stuff of science fiction, are now topics of serious scientific inquiry. The physics of the impossible has shown us that the boundaries of what we understand are constantly being pushed, challenged, and redefined. It's a testament to the power of human curiosity and our relentless pursuit of knowledge. Yet we've only scratched the surface of what's possible. There are still countless mysteries waiting to be unraveled, countless ideas waiting to be explored. The journey towards understanding the impossible is far from over. It's only just begun. Thank you for joining us on this journey. Don't forget to subscribe to Investigating the Universe and like and share this video. Until next time, keep exploring the impossible.